Hi guys, welcome back to my channel. For today, we're going to talk about a new math lesson or math concept about polynomial functions. But before that, please don't forget to hit the subscribe button and the notification bell for more videos. So my YouTube name is Teacher Dong. Please subscribe and hit the notification button. Now, so let's talk about Descartes' rule of signs and finding rational zeros. This is still part of our chapter about polynomial functions. Actually, in this part, this is actually a preparatory in graphing polynomial functions. So our concept or math concepts for today is divided into two. So we have the first one, Descartes' rule of signs. So when we say Descartes' rule of signs, this was actually the conventional method in identifying the signs of the signs or the number of signs of the possible positive zeros. When we say zeros, these are the roots. Okay? So when you get the factor and then solve for the variable, and then you will be getting the zeros or the roots. So in this case, you will be able to count first if how many are the possible positive zeros and possible negative zeros. So this was actually introduced by René Descartes, a famous mathematician. Now, so let's have the rule of about or let's have the definition of Descartes' rule of signs. If the terms of a polynomial function p of x are written in decreasing order according to the powers of x, so in this case, the first thing is you have to check if the polynomial function is arranged in descending order. So from the term with the highest degree or highest exponent up to the term with the lowest degree or exponent. But in this case, since we're not dividing or we're not using synthetic division and long division here or synthetic substitution, it's okay if the terms are missing. If there are missing terms, do not include them anymore and put 0. So just ignore it. For as long as it is arranged properly in descending order, there's no problem with that. Now, each pair of successive coefficients with opposite signs is called variation of signs. So when we say variations of signs, it means that one variation or alternate signs, when we say alternate signs, one is positive and then beside it is negative or vice versa, negative, positive. That is counted as single variation of signs. So therefore, that's counted as one positive or negative. Okay? Now, theorem. Every polynomial with complex coefficients and positive degrees n has exactly n complex roots. So what do we mean by that? Okay, so whatever is the degree of the polynomial, let's say it's cubic or the highest exponent among the terms is 3 or square or 2. Okay, so that is also the number of roots or zeros of the polynomial function. So the number of complex roots depends on n or the value of the degree of the polynomial or the highest exponent. Please don't forget about that. So you will understand more Descartes' rule of signs when we discuss the examples. Now, if a polynomial equation with real coefficients has exactly or has a plus bi as a root, where a and b are real and b is not equal to 0, then a minus bi is also a root. So what do we mean by this? Let's say you're not able to identify possible positive or possible negative, or you still have to complete the number of possible positive or the number of the degree. Okay, so the remaining then are what we call imaginary zeros. So we're not only counting positive, negative, we are also counting the number of imaginary zeros depending on the number of positive and the number of negative zeros that you are able to identify. Now, let's have the rules for positive, or how are you able to count the number of possible positive zeros and possible negative zeros with this. Let p of x be a polynomial function with real coefficients. Then, the first is the rule for positive. The number of positive real zeros or roots or of p of x equals 0 is either, so we are talking about positive real zeros, is either equal to the number of variations in sign of p of x or is less than this number by a positive even integer. So it means that you will substitute x, of course, to positive x. So therefore, whatever is the given polynomial, okay, so that's the one that you will use. So in that case, you're able to get the variation of signs if there is, and you're able to count the possible the possible positive zeros. Now let's have number 2. This is the rule for negative. The number of negative real zeros or roots of p of x equals 0 is either equal to the number of variations in sign of p of negative x. So to identify the number of possible negative zeros, you have to substitute x to negative x. So p of negative x or is less than this number by a positive even integer. Okay? Next. So to better understand Descartes' rule of signs, of course, we have to apply it to the different examples that we're going to have. Example 1. Determine the possible number of positive and negative real zeros of p of x equals x cubed plus 7x squared plus 14x plus 8. So in this case, of course, we will be identifying if how many possible positive zeros, negative, and imaginary zeros do we have in this polynomial function. But first of all, we have to check if this is arranged in descending order, ignoring the missing term if there are missing terms. Now, so as you can see, the highest exponent or the degree is cubic. So, cubic, quadratic, linear, and then constant. So therefore, it is arranged from the highest degree up to the lowest degree. So there's no problem with the arrangement. Now, so according to the fundamental theorem of algebra, so whatever is the degree of the polynomial is also the number of terms. So the total number, number of zeros rather, the total number of zeros or roots is 3. Okay? 3. Now, let's continue. So first is we will be identifying the possible zeros. So we will be substituting x to p of x or whatever is the given here. Now, p of positive x, okay, so we will be writing the terms as it is. So x cubed plus 7x squared plus 14x plus 8. Okay? So then the next thing is you will identify if there are variations of sign. Okay, so in this case, we don't have. When we say variations, there must be terms or terms with alternate signs. In this case, this term is positive, this term is positive, this term is positive, this term is positive as well. So therefore, there is no negative. We can now conclude that there is no variation of signs. So therefore, we don't have possible positive zeros. So we are looking for 3. So it means that we have to proceed and verify the 3's if the 3 roots are negative. If they are not negative, okay, we can proceed in putting them under imaginary. So to identify the negative or possible number of negative zeros, you have to substitute x to negative x. So you change x to negative x. So negative x cubed plus 7 times negative x squared plus 14 times negative x plus 8. So, let's simplify this. So, if the exponent of the term is odd, okay, what are the odd numbers? We have 1, 3, 5, 7, and so on and so forth. Okay, so, the sign of this will become negative. So, negative x times negative x is positive, x times negative x. So, this is equal to negative x cubed. And then if the exponent of the term is even, so therefore this will become positive because negative x times negative x is positive x times 7. This will become positive 7x squared. And then 14 times negative x is positive 14 or rather negative 14x. So it's negative 14x. And then bring down positive 8. Then the next thing, let's say identify the variations, okay, the number of variations of signs for negative. So this term is negative, this term is positive, this term is negative, and this term is positive. So we have the first variation that is counted as one variation. So we have the second variation and the third variation, positive, negative, positive, that's counted as one. Positive, negative, that's counted as the second variation, and then negative, positive, that's counted as the third variation. So we are able to identify whatever are the variations, that's the number of the possible negative. So in this case, we have 3 negative. So we are looking for only 3 zeros or roots. So therefore, we don't have imaginary because if we're going to add them all, 0 plus 3 plus 0, this is 3. But according to the rule a while back, if if the number of 0 is more than 2 or more than the first even number, which is 2, you have to subtract 2. Okay? So 3 is more than 2, right? So therefore we will be subtract 2. That is fixed. So if there's a number of 0 which is more than 2, you have to always subtract 2 from it. So 3 minus 2 is 1. So teacher, we are looking for 3 zeros. So in the second row, we can say that the two remaining zeros are imaginary. So how are we going to interpret the table? So there's a possibility that we only have 3 negative zeros, or in the second row, there's a possibility that we have 1 negative and 2 imaginary zeros, but still we don't have positive because we're able to find out that there's no variation of signs for positive. Okay? So this one, 0 plus 1 plus 2. So if you are going to ask me, so when to have a second row, just like this. So if in the first row, there's a number of 0 which is more than 2. In this case, 3 is more than 2. That's why we have to always subtract 2 from the number which is more than 2. So 3 minus 2 is 1. So I will repeat that. So we will stop until such time that the number of 0 is equal to 2 or less than 2. Just like this, we have 1, and this, we have 2. Okay? Let's proceed. Example 2. Determine the possible number of positive and negative real zeros of p of x equals x raised to the fifth minus 3x raised to the fourth plus 3x cubed minus 9x squared plus 2x minus 6. So in this case, still we're going to identify how many are positive, negative, and imaginary. So first thing is we will begin with the positive. So we will substitute x to positive x. So whatever is the given, that's the one that we are going to use. In this case, we have p of x equals x raised to the fifth power minus 3x raised to the fourth power, or rather, yes, it's negative 3x raised to the fourth power plus 3x cubed minus 9x squared plus 2x minus 6. Okay? So let's now observe the terms. This is positive, this is negative, positive, negative, positive, negative. So this one is one variation, positive, negative. Second variation, negative, positive. Third variation, positive, negative. Fourth variation, negative, positive. And then lastly, positive, negative. We have 5. So in this case, we're able to identify that there are 5 possible positive zeros. So we will be writing 5 here. How many are we looking for? 5, because the degree of the polynomial function is 5. So that's why, okay, so the degree is, or the number of zeros or roots will also follow. It's also 5. Okay? Now, the question is, are we going to proceed, teacher, with the negative or identifying p of negative x to get the variation of signs for possible negative? No, because we're able to identify that all the zeros or the signs of all the zeros are positive. Okay, so 5. So it means that we can actually write 0 here and also 0 here. So 5 plus 0 plus 0 is 5, which is also the degree of the polynomial. And then is 5 more than 2? Yes, so we have to subtract, or we need to subtract 2 from it. So 5 minus 2 is 3. 0. And then we have to have 5, so therefore the remaining, they are always imaginary. So 3 is still more than 2. That's why we are going to subtract 2. 3 minus 2 is 1. 0. And then the remaining 4 are imaginary. Okay? We don't care about the imaginary. We're not going to subtract from 4, so rather we are only subtracting if the number of possible positive and negative are more than 2. So 1 plus 0 plus 4 is 5. So we are able to have the second row and the third row because of the number of possible positive zeros. They are more than 5. More than 2 rather. Okay? So this is now your answer. This is your answer, this table. Next. Third, determine the possible number of positive and negative real zeros of f of x equals 2x raised to the fourth plus 3x squared minus x minus 1. So in this case, as you can see, it is arranged in descending order, but the terms are incomplete, but we don't care about that. What is important is the terms are arranged in descending from the highest degree up to the lowest degree. Still, we are going to identify the number of possible positive, possible negative, and imaginary. Okay? Next, let's start first with a positive. Okay? So f of x or positive x, just write the given, 2x raised to the fourth plus 3x squared minus x minus 1. By the way, how many zeros do we have or roots? We have 4. Okay? So we will be identifying if how many are positive, negative, and imaginary among all those 4 zeros or roots. So in this case, this is positive, positive, negative, negative. So we only have one variation, positive, negative. So therefore, we have one possible positive. We're still looking for the other 3 since the degree of the polynomial is 4. Okay? Now let's proceed to negative. So f of negative x, just change x to negative x. So 2 times negative x raised to the fourth plus 3 times negative x squared minus negative x minus 1. Then the next thing, let us simplify. This is even, so this will become positive. 2 times positive x raised to the fourth is 2x raised to the fourth. This one is even, so therefore this will become positive. So 3 times x squared is positive 3x squared. And then we have negative times negative x, positive x, bring down negative 1. Do we have variations of signs? We have, okay, positive, 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 negative. We have 1. So we have 1 positive, 1 negative. What will happen to the remaining 2? You have to assume that they are imaginary. 1 plus 1 plus 2 equals 4. Are we going to have a second row, third row? No. Because as you can see, among all the values, 1, 1, 2, there's no more than 2. Okay? So let's proceed. That's it for Descartes' rule of signs. Now, we are going to use this as the first step in solving or finding the integral or rational zeros of polynomial functions. That is now the next part of our lesson, finding rational zeros. So for my students, you can read more about this from page 105 to 113 of your books. Let's proceed. This one is the easiest. Now, there are 2 ways. If the given polynomial is factored, you can easily identify the zeros, just like this one. But if the given polynomial function is like the examples that we had in the Descartes rule of signs, you have to undergo the 3 steps, okay, in solving for the integral and rational zeros of polynomial functions. So let's have the easier, okay? So multiple zeros of a polynomial. So if a polynomial p of x has x minus r occurring as a factor exactly k times, then r is 0 of multiplicity k of the polynomial function y equals p of x. Now, so r is the symbol for zeros or roots, and k is how many is it in a specific polynomial function. Okay, how many factor is it in a specific polynomial function? We call it multiplicity of the 0. Okay, now we have p of x equals x minus 3 squared times x plus 2 cubed times x plus 1. Alright, so as you can see, they are factored. You can easily solve for this. X minus 3, opposite of negative 3 is positive 3. As easy as that. X plus 2, the opposite of 2 is negative 2. X plus 1, the opposite of 1 is negative 1. So we're done. The zeros are 3, or the roots are 3, negative 2, and negative 1. So how many factors do they have, okay, in the polynomial function? For 3, just look at the exponent, that is the k, 2. Okay, it serves 2 factors in the specific polynomial function p of x. Now, how about negative 2? It occurs 3 times. And then for negative 1, it is understood that there's an exponent of 1 there, okay? So therefore, negative 1, we have 1. This is now your answer. Okay, as easy as that. Let's have one more example, same as this. Okay, example 5. Find the zeros and multiplicity of zeros of the polynomial function f of x equals x squared times x minus 3 squared times x plus 4 squared. So this is now our factored form polynomial function. Now, let's proceed. Let's begin with this one. X minus 3 This one is conventionally it goes like this. X minus 3 equals 0. You will equate them to 0 to solve for x. Then follow the addition property of equality to isolate x. So therefore this one is x, and the opposite of negative 3 is positive 3. And then here, x plus 4 equals 0. X equals to the opposite of 4, which is negative 4. So we are able to have 3 and negative 4. How about this x? This x, you just equate it to 0. So therefore, one of the zeros is 0, or the origin. So we have 0, 3, and negative 4. But you still have to arrange it in ascending order from negative 4, and then 0 and 3. Now, let's not mind about that. So how many zeros do we have? Or x equals 0? We have 2. Just look at the exponent. How many 3 do we have? We have 2 as well. How many negative 4 do we have? We have 2 as well. So we are able to identify the zeros and the multiplicity, or k. That's it. If the given polynomial function is factored, that's the thing that you're going to do. What if we have the simplified? Okay, so we are going to have finding integral zeros. When we say integral zeros, we don't have fraction, but still integral and rational, they are still the same. You will be asked to solve for the zeros. Okay, finding the integral or rational zeros of polynomial functions, but in rational, we will be using rational zero theorem. To avoid confusion, even for the integral zeros, we are going to use the rational zero theorem. So finding integral zeros of polynomial functions. Let p of x be a polynomial function in x with integral coefficients. Then the only possible integral zeros of p of x are the divisors of the constant term. Okay, the constant term. Okay, so we are going to use the constant term in finding the exact zeros, or identifying the possible zeros, and later on solving the rational the integral zeros. Now, fundamental theorem of algebra, this is the same as the previous one under Descartes' rule of signs. Whatever is the degree, that is also the number of zeros. Okay, rational zero theorem. Given a polynomial function defined by p of x with integer coefficients and where n is a non-negative integer, the possible rational zeros of p of x are of the form p over q. P, we have the factors of the constant, and q, we have the factors of the coefficient. So we need to divide, where p is a factor of a sub a of 0. So therefore, guys, there's a possibility that there's a fractional zero or root. Okay, now, how to identify the possible zeros here? You will be using the factors of the constant divided by the leading coefficient. The leading coefficient is the coefficient which is beside the term with the highest exponent. And the constant term, of course, is the 0 degree term of the polynomial function, if there is. Now, let's proceed. Suggestions to consider in finding the rational zeros. Step 1. Use the Descartes' rule of signs in finding the number of possible positive and negative zeros, just like what we've done in the previous part of our lesson for today. Step 2. Use the rational zero theorem p over q in finding the possible zeros, just like this, p over q, where in p we have factors of the constant divided by the factors of the coefficient. Now, step 3, that's the time that you will be solving the exact zeros or roots using the synthetic division, or maybe to make your life easier, you can just use direct substitution. But as right now, please prepare your calculator so that you will be able to follow our lesson, and of course a paper, because we have 3 steps here. Okay? Then the next thing is, let's have this. List all the possible integral zeros and solve for the integral zeros of the polynomial function f of x equals x squared minus 5x plus 6. Okay? Now, let's proceed to step 1. In step 1, we are going to use the Descartes' rule of signs. So let's just use the acronym DRS. Sorry, the Descartes' rule of signs. Then the next thing is, of course, we will be identifying the possible positive, negative, and imaginary, so that we will be guided if how many are we going to solve. So how many positive, how many negative, and imaginary. Okay? Now, let's proceed. For positive, okay, based on our rule, just copy the given f of x and make sure it is arranged in descending order. X squared minus 5x plus 6. F of x equals x squared minus 5x plus 6. So count the variation of signs. This one is positive, negative, positive. So 1, 2. So we have 2 positive. And according to the degree of the polynomial, we only have 2. So therefore, we don't have any more negative and imaginary. Assume that. Do not anymore proceed to f of negative x. Then the next thing is step 2. Let's use the rational zero theorem. P over Q. Okay, wherein P is the constant or factors of the constant, which is positive 6, and it is understood that Q is 1 here. It's beside the term with the highest exponent, which is 2. That's understood, okay? From now we have P and Q. And then the factors of 6 are, when we say factors, when you multiply them, you will be getting 6, just like 2 times 3 and 1 times 6. So the factors are positive 1, positive 2, positive 3, and then, no, positive negative 6. We have positive negative 1, positive negative 2, positive negative 3, and positive negative 6. And then factors of 1, of course, we only have positive negative 1. Now, we are able to identify now the possible zeros by dividing. 1 divided by 1, we have positive negative 1. 2 divided by 1, we have positive negative 2. 3 divided by 1, we have positive negative 3. And then 6 divided by 1, we have positive negative 6. Okay, so according to the Descartes rule of signs, we're going to have only 2 possible positive. So therefore, we will just be trying positive 1, positive 2, positive 3, and positive 6. Okay, so let's proceed first to positive 1. Okay, step 3. We will now be using direct substitution. Okay, direct substitution. So let's start with f of 1. So on your calculators, just change x to 1. So we have 1 squared minus 5 times 1 plus 6. Let us simplify this. 1 times 1 is 1. Negative 5 times 1 is negative 5 plus 6. This must be equal to 6. 1 minus 5 is negative 4 plus 6. Okay. We have 1 times 1, 1. Then negative 5 times 1, which is negative 5. Then bring down 6. So 1 minus 5 is negative 4. Plus 6, we have positive 2. So this is none one of the zeros or roots. If that's not, we are doing the trial and error method. Okay. Proceed to f of 2. F of 2 is 2 squared minus 5 times 2 plus 6. So 2 times 2 is 4. Negative 5 times 2 is negative 10. Bring down 6. 4 minus 10 is negative 6 plus 6. This one is 0. So therefore, 2 is one of the zeros. Okay? We need only one more. Let's try f of 3. If f of 3 is not equal to 0, therefore we go to 6. So f of 3, just change x to 3. Okay, so 3 squared minus 5 times 3 plus 6. So 3 times 3 is 9. Negative 5 times 3 is negative 15 plus 6. Okay, so 9 minus 15 is negative 6 plus 6. So this one is 0. Therefore, we also have 3. And then we stop there because we are only looking for 2 possible positive. And the degree of the polynomial is only 2. So we will stop there. Okay, so that's the process. Now, therefore, we can conclude that 2 and 3 are the zeros of f of x. So, we have 2 and 3 as the zeros. We're able to satisfy the Descartes rule of signs of having only 2 positive. And of course, okay, among all the possible zeros, we are able to get 2 correct zeros. Now, let's proceed. Example 7. List all the possible integral zeros and solve for the integral zeros of the polynomial function p of x equals x cubed minus x squared minus 10x minus 8. Step 1, we are going to use the Descartes rule of signs. So for the Descartes rule of signs, we will be identifying the positive, negative, and imaginary. So that's how important is Descartes rule of signs in finding the integral or rational zeros. Okay, so let's proceed to this one. To identify the positive, of course, we will substitute x to positive x. So just copy the given. P of x equals x cubed minus x squared minus 10x minus 8. Then after that, okay, positive, negative, negative, negative. So we only have one variation of signs. Okay, and according to the given, we have 3 zeros. So if that's the case, we are still looking for 2. Just assume that we have 2 negatives so that we will shorten the process. Do not try anymore in finding p of negative x. Don't worry for my students in our examination. When you are tasked to find the rational zeros, I'm not going to give any imaginary values. Okay, so step 2, we are going to have p over q. Okay, our p is negative 8 and our q is of course 1. Okay, p over q. Factors of negative 8 are positive negative 1, we have positive negative 2, positive negative 4, then we have positive negative 8. And then for q, we have positive negative 1. Okay, positive negative 1. Then, let's have the possible zeros. Let's divide them one by one. 1 divided by 1 is positive negative 1. 2 divided by 1 is positive negative 2. Then, 4 divided by 1 is positive negative 4. And 8 divided by 1 is positive negative 8. So we are able to have now the possible zeros as positive negative 1, positive negative 2, positive negative 4, and positive negative 8. And among these possible zeros, we are looking for 1 positive and 2 negative zeros. So to shorten the process, I will just be telling you the numbers to try. But in reality, you have to try them all until such time that you're able to identify the right signs. Okay, or number of possible positive and negative. So in this case, let's try among the zeros, let's try p of negative 1. So just change x to negative 1 cube minus negative 1 square. So let's erase this. Okay, so negative 1 cube minus negative 1 square minus 10 times negative 1 minus 8. Okay, simplify this, you will be getting 0. So therefore, negative 1 is one of the zeros. So we're still looking for 1 positive and 1 negative. So the next thing is you can try positive 2, but it's not the 0. Now you can try p of negative 2. So p of negative 2, when you change all x to negative 2 in your calculators, you have to get 0 as well. So therefore, negative 2 is 1. Then we are still looking for 1 positive. So therefore, you're not going to try anymore the remaining negative possible zeros. Rather, you will try only the remaining possible positive zeros. Okay, so in this case, we have only 4 and 8, positive 4 and 8. So let's try p of 4. Okay, so you have to get as well 0. So therefore, we can say that, but in reality, warning, you have to try all the possible zeros. Okay, so we are just actually shortening the process, or I'm just giving the right answers so that we are able to finish this in the shortest possible time. So therefore, the possible zeros are negative 1 or negative 2, negative 1, and we have 4 are the zeros of, okay, we used p of x. So negative 2, negative 1, and 4 are the zeros of p of x. So as you can see, we have 1 positive and 2 negative zeros. Next, example 8. List all the possible rational zeros and then solve all the rational zero of the polynomial function p of x equals 2x squared minus 5x minus 3. Okay, so let's have number 8. Step 1, we are going to use the Descartes rule of signs. Okay, so we will be counting if how many are positive, negative, and imaginary. Then the next thing is, okay, let's identify the positive. We have P of positive x equals, just copy the given, 2x squared minus 5x minus 3. We have positive, negative, negative, so we only have one alternate signs, and this is counted as one positive. And in the given, we are only looking for 2. So let's assume that the remaining is negative, and we have 0 imaginary. Do not proceed anymore to P of negative x, but if you would like to verify, you can proceed. Then let's have step 2, or the rational zero theorem, P over Q. Our P here is negative 3. We will be identifying the factors of negative 3, which will serve as the dividend. Okay, so and then 2 is our leading coefficient, so therefore this is your Q. In the previous two examples, it's 1. Okay, so factors of 3, we have positive negative 1 and positive negative 3. Then factors of 2, we have positive negative 1 and positive negative 2. Then divide 1 divided by 1. So we're now down with the possible zeros. 1 divided by 1 is positive negative 1. 3 divided by 1 is positive negative 3. Then 1 divided by 2 is positive negative 1 half. Okay, so we have negative, we have fraction. Okay, and then 3 divided by 2 is positive negative 3 halves. So these are the possible zeros that we're going to try in step 3, or the direct substitution. So for the direct substitution, guys, okay, so I will be giving you the numbers that to try. But in reality, again, you have to try them all. We're looking for one positive and one negative. So you try first positive 1, then negative 1, and then proceed, if you're not able to get, proceed to P of 3. So change all x to 3. So 2 times 3 square minus 5 times 3 minus 3. So if you will be simplifying this using your calculator, you will be getting zeros, and 3 is one of the zeros or roots. So we call them zeros because the remainder, or the value of the polynomial that we get, is always 0. And then we already have one positive, we're still looking for one negative. So try negative 3, it's not, and then proceed to the fraction, negative 1 half. Let's try negative 1 half, P of negative 1 half. So just change all x to negative 1 half. Square minus 5 times negative 1 half minus 3. On your calculators, you have the fraction symbol like this on the upper left, I think. Or in other calculators, the symbol that is showing is this. Okay? So, you can write it as negative 1 half on your calculators, or negative 1 half, the older model. Now, so you have to get 0 as the remainder here. So therefore, the zeros are negative 1 half, which is the lower value, or 0, and 3 are the zeros of P of x. See? Following the Descartes rule of signs and the possible zeros, we're able to identify the two zeros, negative 1 half and 3. Okay? Now, let's have the last. Number 9. List all the possible rational zeros and then solve all the rational zero of the polynomial function f of x equals 15x raised to the 4th minus x cubed minus 17x squared plus x plus 2. So it is arranged in descending order, and then we have 4 total number of zeros or roots. Step 1. DRS, or the Descartes rule of signs, we will be identifying the positive, negative, and imaginary. And then after that, okay, so proceed now to positive, which is the P of f of x. So that's the one that was used, f of x. Okay, equals, just copy the given, 15x raised to the 4th minus x cubed minus 17x squared plus x plus 2. So we have positive, negative, negative, positive, and positive. So this is one variation, second variation. Okay, so in this case, we're able to identify that 2 of the 4 zeros are positive, and then assume that the remaining are negative. So 2 plus 2 equals 4. So we are looking for 2 positive, and then if you want, you can verify by proceeding to f of negative x. There's no problem with that. So 2 plus 2 plus 0 equals 4. Now we can proceed to step 2. P over Q. So in this case, our P is positive 2 and our Q is 15. Okay, so for the factors of 2, we have positive negative 1 and positive negative 2. Then for the factors of 15, we have positive negative 1, positive negative 3, positive negative 5, then positive negative 15. Now, let's identify the possible zeros. So the possible zeros are 1 divided by 1 is positive negative 1, 2 divided by 1 is positive negative 2, 1 divided by 3 is, yes, 1 divided by 3 is positive negative 1/3, then 2 divided by 3 is positive negative 2/3, and then we're down with the 5. So 1 divided by 5 is positive negative 1/5, and then 2 divided by 5 is positive negative 2/5. And then lastly, 1 divided by 15 is positive negative 1 over 15. Then 2 divided by 15 is positive negative 2 over 15. So 4 of these possible zeros, we have 16 possible zeros are only the correct answers. Now we can proceed to step 3. In reality, again, you have to try them all until you get the right zeros. So in this case, let's proceed. Now I will be giving or orchestrating the zeros that you have to try. So but first, you have to start from positive 1 and negative 1. Okay? So let's proceed to positive 1. Let's try if it is one of the zeros. So positive 1. Just change x to zeros. Or rather, just change x to 1. I'm sorry. So we have 15 times 1 raised to the 4th minus 1 cube minus 17 times 1 square plus 1 plus 2. So you have to get 0 here because P of 1 is 1, or 1 is one of the zeros. So we're still looking for 1 positive and 1 negative. So let's try P of negative 1. This is also equal to 0. Now, we're still looking for 1 positive and 1 negative, but you have to try all. Okay, so try positive 2 and negative 2. If they will not work, you can proceed to P of negative 1/3. So P of negative 1/3 is equal to 0. Okay, so we're still looking for 1 more positive, so proceed to the other one, P of 2/5. So P of 2/5 is also 0. Okay, so we're able to have 4. Therefore, we can say that the zeros are negative 1, negative 1/3, 2/5, and 1 are the zeros of f of x. Sorry, my pen is malfunctioning. Okay, so we have negative 1, negative 1/3, 2/5, and 1 are the zeros of f of x. Okay, so let's proceed to the problem solving number 10 using finding rational zeros. The volume of the rectangular block is 88 cubic inches. The width of the block is twice the height and the length is 9 inches more than the height. Find the dimensions of the block. Okay, so in this case, we're talking about a rectangular block. Let's draw. Let's say this is a perfectly made rectangular block. I'm so sorry about my illustration. Okay, and then for the formula, we have volume equals length times width times height. Okay, so this is your length, this is your width, and this is your height of the rectangular block. And according to the given, the volume is equal to 88 cubic inches. While, so in identifying the representation, you have to take note if, which is the lowest dimension. In this case, if height is mentioned twice, so therefore this is the lowest dimension, which will serve as your variable, which is h. Okay, and according to the given, the length is, or rather the first one, the width of the block is twice the height, so therefore this is 2h. Okay, and then The width is 2h. And then for the length, according to the problem, it's 9. The length is 9 inches more than the height. So when we say more than, that is addition. So length is h plus 9. And your height is h, of course. And the unit of measurement for the dimensions, of course, is it's inches. Then you have to form your polynomial equation. So according to the formula, it's v equals length times width times height. Substitute, we have 88 equals the length, which is h plus 9, times the width, which is 2h, and the height, which is h. Then, okay, let's proceed from the lowest. We have h times 2h. Bring down h plus 9 first to make your life easier. 2h plus h, or h plus 2h times h, or h times 2h is 2h square. Then distribute the binomial to the monomial to the binomial. So we have 88 equals 2h squared times h is 2h cubed. Then 2h squared times 9 is 18h square. Then the next thing is we have to arrange this, which is equal to 0. Get the opposite of 88. Alright, so we have copy this one. 2h cubed plus 18h square. We did not do anything with 2h cubed plus 18h square. And the opposite of 88 is negative 88, and then equate to 0. Then as you can see, the numbers or the coefficients are all even, 2, 18, and negative 88. So we can still simplify this by dividing without GCF, which is 2. 2 divided by 2 is h cubed. Then 18h squared divided by 2 is 9h squared. Then negative 88 divided by 2 is negative 44. And then 0 divided by 2 is 0. So we have now the polynomial equation, which is h cubed plus 9h squared minus 44. This will serve as our equation. That's the only time that we can proceed to step 1. So for step 1, we're going to use the Descartes rule of signs in identifying the positive, negative, and imaginary. So this is the given. Okay, we have h cubed minus 9h squared minus 44. P of x. This is positive, negative, negative. So we have one variation. So we have one positive, and the degree of the polynomial is 3. The other 2 are negative. So in this case, since we're talking about dimensions, so we don't have a negative measurement. So therefore, we will only solving for one positive. So we stop there. We can now proceed to step 2. So for step 2, we will be having P over Q. Wherein your P, according to the equation, it's negative 44, while your Q is 1. So P over Q. So the factors of 44, we have negative 44, positive negative 1, I'm sorry. We have positive negative 1. We also have positive negative 2, positive negative 4, 8 is not. Okay, we have positive negative 11, positive negative 22, then positive negative 44. Okay, so then factors of 1, we have positive negative 1. We will only try the positive values, positive 1, and then we have 2, 3, 2, 4, 11, 22, and 44. If I mistakenly write or did not write the possible 0, please inform me. Okay, so we can now proceed to step 3. Okay, first you try P of 1. Okay, so P of 1, we have 1 cubed plus 9 times 1 square minus 44. Okay, so this is not. If you will try it, it's not. The remainder is not 0. Then we can proceed to P of 2. Okay, just change all h to 2. We have 2 cubed plus 9 times 2 square minus 44. So this one is equal to 0. Therefore, the value of h is 0. No. The value of h, I'm sorry about that, is 2. Okay? So 2 is the one that we are going to use. Okay, now we can proceed in writing the dimensions. This is not yet the final answer, rather these are the following answers. So your length is h plus 9. Your length is h plus 9. Substitute h, which is 2 plus 9. Therefore, the length is 11 inches. And then for the width, we have 2h. Okay, substitute 2 times 2. This is equal to 4 inches. And then lastly, the height, we have, of course, equals 2 inches. So therefore, the dimensions of the block, we have 11 inches by 4 inches by 2 inches. This will serve as your final answer. Okay, so to check, when you multiply the 3, you have to get 88. 11 times 4 times 2, it's equal to 88. Alright, so this is now the dimension. These are the dimensions of the rectangular block. Okay, so if you have questions, I think the second part of the lesson, which is the finding rational zero, is quite complicated. If you have questions and clarifications regarding this topic or concept, please ask me. Okay, so if I have mistakes or what, you please inform me as well. Okay, for my students, you will do this activity. Okay, and then we will be checking it, or you will be submitting it in our next meeting, rather. Now, I hope that you have learned a lot. I'm so sorry about the about my pen tablet, because it's not perfectly working right now. Okay, so thank you so much for being with me. Again, please don't forget to hit the subscribe button and the notification bell for more videos. Okay, so just search on Teacher Dong and then click the subscribe and the notification bell. So thank you so much. Let's see each other in our next math concept or math lesson. Okay, good day everyone.